In section 10.5, we're going to look at some more angle relationships in circles. We've talked about central angles, inscribed angles, and we're going to look at a few other angle types in circles. Now the first thing, we're going to start with something we already know. An inscribed angle, like you're seeing in this circle here, remember an inscribed angle has its vertex on the circle, like this angle does. And we know that its measure is what compared to its intercepted arc. Remember how central angles were the same measure as their arcs because they were at the center, and so they do the same amount of 360 as a whole circle. But an inscribed angle, remember, was half the measure of its intercepted arc. Now that's going to be true even if one side of the angle is tangent to the circle. Let me show you what I'm talking about here. If I grab this chord that made the inscribed angle, if I extend it a little bit further, you'd say, hey, this is still an inscribed angle. It's still half of the measure of the intercepted arc. I'm going to grab this chord and move it a little bit further and moving it down the circle, and hey, this is still here an inscribed angle, right? And it's still going to be half of the measure of this intercepted arc, which now just goes a little bit further. Well, extend this even further. Still technically an inscribed angle, still half of its intercepted arc, but things get interesting on this next thing that I'll do. If you keep going and you keep going and you bring it even closer, well, eventually you're going to get to the point where this is a tangent line. Now, why is this a tangent line? Because of the fact that it only touches at one point on that circle. Okay? But in this case, this is still like an inscribed angle. It's just that we have a chord and a tangent, and now the intercepted arc goes here all the way back to the meeting place, which is right here. And this angle, this inscribed, it's still like an inscribed angle, it's just a chord and a tangent. It's still going to be half of the intercepted arc, and that's theorem 1011 right here. If a tangent and a chord intersect on a circle, then the measure of the angle here that is formed is going to be half the measure of that intercepted arc. It's really just like the extension of an inscribed angle, as you saw when I just kept moving this. It was still half the arc, still half the arc, still half the arc. Eventually it just becomes a tangent line. Still going to be half of that inscribed, or intercepted arc, sorry. Let's look at some examples here. In all of these, line M is tangent to the circle. You do need to know that for these to work. And I want to find x. In this case, x is the degree measure at vertex B, which is like an inscribed angle. We have a chord AB, and we have this tangent line M. This angle then is half of the intercepted arc that goes from that chord all the way back to its point of tangency. Therefore, x is half of 228 degrees. So therefore, in this case, x is what? Half of 220 would be 114 degrees. And that looks like it could be 114 degrees. And we're all set there. In this example, again, M is a tangent line. Point of tangency is at B. We have this chord AB and tangent line meeting here. I have the angle measure of this almost inscribed angle, right? Chord and a tangent is 62. I know then that its intercepted arc, which would go from the point of tangency B up to A, would be double that angle measure, so 62 times 2. So 124 degrees. And that looks like it could be about 124 degrees, because if this was diameter, that would be 180 to there. So 124 looks reasonable for that arc from A to B. Again, that is almost an inscribed angle. It's just a chord and a tangent. It's half of the intercepted arc. The intercepted arc is double that angle. I want you to do these two for class. Find the measure of an angle YXZ, which we're talking about this angle right in here. It's an angle formed by a chord and a tangent, therefore it should be half of the intercepted arc. In this one, I want you to find the measure of arc RT. A little bit trickier here. Measure of arc RT, now if they're only doing two letters, they're talking minor arc. So I want the direction from R to T that's less than half of the circle. So I'd have to go this way. Notice we have 98 degrees here, the measure of that angle between this chord and this tangent line. So two ways to do this. Either you can find this sort of inscribed angle, then double to find the arc, or double to find this arc, and then know that the whole circle is 360. So two ways to find that. We'll talk about that in class tomorrow. And here's the big stuff for today. Intersecting lines and circles. Now this is what we've already talked about. If two lines happen to intersect right on the circle, as these do here, you have an inscribed angle. And we've talked about inscribed angles. Their measure is half of the arc. You know that this angle measure right here would be half of whatever this intercepted arc measure is. If this was 40 degrees, this would be 20 degrees. If this was 15, this would be 30. But now we get some more interesting stuff happening. What if you have two lines intersecting at a random place inside the circle? Like these blue lines intersect at a random place in the circle, not the center. And I want to know what's the angle measure of x here. Well, keep in mind that these two angles are congruent. This angle x degrees would be the same as if I put x here because these are what types of angles? Well, these are vertical angles. Now what you do if you have a random place intersecting, a random place for two lines intersecting a circle is you look at the arc, first of all, from that angle, which here was x, so I look at that arc. And then I look at the arc for, I name this v for its vertical arc. Because we know that these two angles are congruent, I know that I'm going to look at the arc and the vertical arc, and really you're looking at the average of these two. So you're going to do half the sum of the arcs, or the average, meaning you add, divide by 2. Okay, so if you want to find angle x, it equals the arc at angle x, the arc at its vertical angle, added together, divided by 2, and that will give you the average of those two arcs. Okay, so random angle in the circle, add the arc and its vertical arc, divide by 2, or find the average. That'll give you the angle inside, and sometimes you need to use this whole equation and solve for one of the unknown arcs. And the last case is, what if you have two lines intersecting somewhere outside of the circle? Now these in this case are secant lines because they hit at 2 points in that circle. Could be tangent lines as well. In this case, I'm saying I want the angle outside. I want this angle x. And its measure is actually half the difference of the arcs. I named this B, this arc, because it's the bigger arc, right? You go further away from that angle x outside, and you have this big arc in between those two secants. And then I named this S for small arc. And so you do big arc minus the small arc divided by 2, and that will give you, or that equals, that angle x outside. So sometimes you need this entire equation, that a random angle x, which is outside of the circle here, where two lines intersect, is equal to the big arc minus the small arc divided by 2. Notice for inside the circle you add the arcs divided by 2, and outside the circle you subtract the arcs divided by 2 to get an angle outside. Okay, let's practice some of these then. Find angle x. Angle x here looks like these two chords just randomly intersect. This is not the center. So to find that angle x, I know it's going to be the average of these two arcs. It's in between 89 and 63. So in this case, remember, to find the average, we're going to add those two arcs, the arc formed by the angle x, plus its vertical arc, right, because these would be vertical angles. So 89 plus 63. And then we'll divide that by 2. We're finding the average. Make sure you hit equals before you divide by 2. And I get that x is 76 degrees in this case. And is that right in between 63 and 89? Yes, it is. Alright, so straightforward example of angle inside the circle. Here a straightforward example of an angle located outside of that circle. Actually, we have a tangent line and a secant segment there. So this angle outside the circle, you should take the big arc between the secant and tangent minus the smaller arc divided by 2. So I'm doing 178 minus 76. Make sure you hit equals, divided by 2. And we're going to get 51 degrees for angle x. That looks about 51 degrees, so feeling good about that answer. Okay. This next example is the first one where you actually have to do a little bit of algebra, a little bit of work to get my solution. In this case, I have 30 degrees being a random angle outside of a circle formed by two secant segments. Now, the way we got that outside angle, like here, is we took big arc minus small arc divided by 2. In this case, I don't have the big arc. The big arc's unknown. But I know that if I would do big arc minus little arc, big arc is x, little arc is 44, I know that. If I did big arc minus little arc and I divided by 2, I get, in this case, 30 degrees. Right, like over here, I did big arc, 178, minus little arc, 76, divided by 2, and I got 51. That equals 51 in this case. Here, I don't know the big arc, so I put x, minus the little arc, 44, divided by 2, I know it equals 30. And now I have to solve this equation. Undo divided by 2 by multiplying by 2. I get x minus 44 equals, well, 30 times 2 is 60. And that means that if I add 44 on both sides, I'm getting x. So x is 104 degrees. And that does look reasonable for that arc. Okay, so this one took a little bit of algebra to actually solve for that unknown. Set up the equation and go from there. A few more tricky ones here. In this example, I have a circle and two tangent lines meeting outside the circle to form this random angle x outside that circle. Now you might be thinking here, when there's an angle outside the circle, I'm supposed to do big arc minus the smaller arc divided by 2 to get that angle x. And you're going, well, I do have the big arc, it's 260. Minus, what's the little arc? We actually do know, because think about this, if these are tangent lines, there's only two arcs in the circle. There's 260 and whatever's left. I know the circle adds up to 360, so this must be 100, right? 360 minus 260. So I know this little arc's 100 degrees, so that these two could add up to 360. So my small arc is 100. I'm doing big arc minus little arc divided by 2, and that'll give me x here. So in this case, 260 minus 100, 160 divided by 2, and x is 80 degrees. And that looks reasonable enough, I guess. Okay. This next example, this is another one where it's an angle inside a circle here. 102 degrees, a random angle inside a circle. I need to find x. Now wait a second here. This angle, or this arc x and this arc 95, that would be for these two angles here, right? X is for that angle and its vertical angle here. Well, do I know these angles actually? Because I'm not going to find x unless I know the angle it's actually referring to and its vertical angle. Well, if this is 102 here, and I know that these are a linear pair, right? These would have to add up to 180. So I actually do know these angles in here. 180 minus 102 giving me 78 degrees. So these angles are 78 degrees. That helps because, thinking back one side here, when we had a random angle inside a circle, remember it's the average of the arc and its vertical arc, so I added 8963 divided by 2 to get x. Here, I'm going to add x and its vertical arc 95 divided by 2 to get 78. And so we're going to have some algebra here. Now, I know that to get 78 degrees, I would add the arc and vertical. So I would add x and 95 together. I would add them divided by 2 because that would average these two arcs, and it would give me 78, that arc in the middle. So seeing that 95 is bigger than 78, this arc has to be less than 78. Let's see here. If I added these two divided by 2, if I average them, I get 78. Let's solve. First, I'll multiply by 2 to get rid of that. I get x plus 95 equals 156. And then I'm going to subtract 95. And I get 61 degrees. And that looks pretty good for that arc, okay? And 78 is right in between 61 and 95. So we're good to go. So I had to use this angle, actually find its, its linear pair, so that I had the arc and its vertical arc. I could average those two divided by, and so add divided by 2 and get that angle in the middle. All right, and this last one is the trickiest of all here. 40 is an angle outside a circle formed by two tangent lines in this case. Now I have this arc as x, and I have nothing labeled for the larger arc. Well, here's the deal. Remember back here on this example when it was an angle outside and it was only two arcs because it was tangent lines again? And I knew this one was 260, and how did I get 100? I said, well, there's only two arcs in this circle, so I know they should add up to 360. So to get 100, didn't I really do 360 minus 260 to get what's left for this arc measure here? That's going to be the same idea here. If this much is x, how much is this major arc? Well, I know that this arc x and this one would add up to 360. So to figure out what's left for the big arc, I would take 360 and subtract whatever x is. Right, like here, I did 360 minus what I had, which is 260 to get 100. To find this arc, I do 360 minus whatever I have, which is x. That would give me the big arc. So now, with this angle outside, with an angle outside a circle, I know I'm doing big arc minus small arc divided by 2 equals, in this case, the angle outside, which is 40. The big arc is the one I just named 360 minus x. There's the big arc. Now I'm supposed to subtract the small arc. Now the smaller arc was just x. And I know that I then divide by 2, and that gives me an angle outside a circle, which in this case it's 40 degrees. Setup looks a little scary here, but solving won't be too bad. First I'm going to multiply by 2 to get rid of that whole divide by 2 there. Also, this is 360 minus x minus another x. Well, minus x, combine those like terms, that's really subtracting 2x. So 360 minus 2x equals 40 times 2 is 80. Let's subtract 360 on both sides to get rid of this. So I'll just have negative 2x here, and I'm doing 80 minus 360 on this side. I get negative 280, and divide by negative 2, and this will turn to x will be positive 140. Okay. And that looks pretty good. If this was 140 degrees, then the bigger arc, think about that, it would have been 360 minus 140. So 220. And then 220 minus 140 would be 80. 80 divided by 2 is 40. So today, looking at those special inscribed angles, which are actually chord and a tangent, being half of their intercepted arc, looking at angles inside a circle, where you add the arc and its vertical, divide by 2, and looking at angles outside a circle, where you take big arc minus little arc, divide by 2.